Hello everybody, in this video we're going to talk about how to graph a quadratic function that is in vertex form. So really there's kind of two ways to do this, and we've already looked at the first way in previous videos, and that's by using transformations. So in this video we're going to talk about how we can do this by using the axis of symmetry of the function and the vertex of the function. So look at our little diagram here. We see our x and y axis, that's in white. We see our parabola there in black, and we have a couple other things to note. So our blue vertical line, it's a dashed line, that is known as the axis of symmetry. So that's a vertical line that goes right through our vertex, and it's going to have the same, or it's going to have an equation that is equal to the x coordinate of the vertex. So that's why we see it as x equals h. And our vertex is the lowest point on our parabola here. Remember, if this parabola were to open down, it would be the highest point. But our vertex is located at h comma k. All right, so let's take a look at an example. And we're going to graph on our coordinate plane here. So we want to graph f of x equals 0.5 times x plus 4 quantity squared minus 2. So the first thing we should do is identify our constants here. So what is a? Well, a is 0.5. What is h? Okay, right now it looks like plus 4, but remember, this starts off as x minus h. So in order for this to become plus 4, h was actually a negative 4, right? Because x minus negative 4 becomes x plus 4. And we have a k value of negative 2. All right, so now we can plot our vertex because we have h comma k, so we'll go ahead and write that here. Our vertex is going to be negative 4, negative 2, so we can go ahead and plot that, negative 4, negative 2. And our axis of symmetry, so axis of symmetry is going to be x is equal to negative 4. So now we can just draw our vertical line through our vertex. I'm going to make it a dashed line because it's not really part of our parabola, like visually, right? It's just there, it's imaginary. But what that axis does is it splits our parabola into two symmetric pieces. So we could like fold our parabola over the axis of symmetry, and the two parts left and right would map on top of each other. So now what we can do is we can pick two x values either to the left or to the right of our axis of symmetry, so either to the left of negative 4 or to the right of negative 4, and we can plug them back into our original equation up here for x to find a couple other coordinates on our parabola. All right, when we do this, let's pick 2 points that are both to the right or both to the left, because once we do that, if let's say we choose 2 points that are to the right of our vertex, we can then reflect those 2 points over the other side, and we have 5 points now for our parabola. So if I look at my equation, I notice I have a 0.5 in there. I'm going to be multiplying by 0.5. So what I'm going to do is choose two even numbers to plug in for x so that I know when I'm multiplying by 0.5, I'm not going to have to work with a fraction. So I'm going to plug in, let's evaluate. So let's write it right here. We're going to evaluate when x is equal to negative 2 and when x is equal to 0. So that's negative 2 and 0, right? So those are two x values that are to the right of my vertex. And so now we're going to come up here and we're going to say, all right, let's find the f of negative 2. So we're just going to plug in negative 2 for x. So 0.5 times negative 2 plus 4 squared minus 2. And now we're just going to evaluate. So I'm going to kind of do this one step at a time. Negative 2 plus 4 would be 2. 2 squared would be 4. 0.5 times 4 would be 2, and 2 minus 2 would be 0, which means we have a coordinate at negative 2 comma 0. So now we can plot that point right there. Now we're going to evaluate when x is 0. So we're going to say the f of 0 is equal to 0.5 times 0 plus 4 squared minus 2. And once again, we're going to evaluate. So 0 plus 4 is 4. 4 squared is 16. And half of 16 would be 8, and 8 minus 2 would be 6. So we have a point at 0, comma 6, and we can plot that right there. And now we have the right side of our parabola, and we can take negative 2, 0, and 0, 6, and reflect those 2 points on the other side of my vertex, or my axis of symmetry. So negative 2, 0 was 2 units to the right, so we're going to have another point that's 2 units to the left of my axis of symmetry. And then 0, 6 was 4 units to the right, so we'll have that point 4 units to the left. So 1, 2, 3, and 4. So now we can go ahead and draw our parabola, and we have graphed our quadratic function in vertex form, right? So that lines up pretty well, and there we go. So that's how you can graph a quadratic function in vertex form.